technological advances during this period opened a new world on astronomical observation. The human senses could now be extended to show exquisite detail in objects otherwise too small or too faint, details which could not be seen by naked eye observations. Johann Kepler picked up Brahe's work after his death. Having a more Copernican belief than Brahe, and using the extensive collection of observational data the Dane had compiled, Kepler went about formulating his 3 laws of planetary motion. Those being the law of ellipses, which states that a planet's orbit is elliptical with the Sun at one focus; the law of equal area, which states that a planet sweeps out equal areas of its orbital plane in equal periods of time. Therefore, the planet accelerates towards the Sun and then slows down as it moves away; and the harmonic law, which gives the relationship between distance from the Sun and speed of the orbit. Through Kepler's work, prediction of planetary movements became more accurate, which in turn made observations more practical. If you could determine where an object should be, it would be much easier to locate and observe. Galileo Galilei pioneered the use of the telescope for astronomical observations. In 1609, he built his first telescope, which had an aperture of 1 inch and was no more powerful than a set of modest binoculars of today. While Galileo did not invent the telescope, he did make refinements to the design, which allowed him to make some startling discoveries. Mountains on the Moon, 4 moons orbiting Jupiter, which we now know as Io, Europa, Ganymede, and Callisto. And he discovered that the Milky Way was actually composed, he believed, of tens of thousands of stars. An unfortunate reality of the time was that in 1633, Galileo was placed under house arrest for heresy, where he remained until his death in 1642. Sir Isaac Newton was one of the greatest minds to ever live. From 1664 to 1667, he invented calculus to allow for calculations involving infinitesimal changes in motion. Then, a year later, he invented the reflecting telescope. Since it is easier to support a large mirror than an equally sized lens, the reflecting telescope allowed for much larger apertures. Work was later carried out by Gregory and then Cassegrain to provide variations on Newton's designs and allow the observation point to be behind the reflector. In 1684, after much urging by Edmund Halley, Newton published his Principia Mathematica. This work described the important inverse square law of gravity, which quantified Kepler's laws of motion. Newton's telescope developments sparked a size explosion, which led to numerous discoveries. Christian Huygens discovered the moon Titan orbiting Saturn, and a year later discovered the Orion Nebula. William Herschel discovered Uranus in 1781. This was the first planet to be discovered beyond the easily visible 5 and served to illustrate how vast the solar system really was. While trying to measure parallax and distance, Herschel discovered binary stars in orbit around one another. The first such pair was Castor in the constellation of Gemini. Herschel continued on to make hundreds of other discoveries using telescopes as large as 48 inches. In the same year that Uranus was discovered, Charles Messier produced a catalogue of 101 nebulous objects. While today this list serves as a roadmap for the amateur astronomer, it was initially compiled to alleviate confusion when searching for comets, which often look nebulous. The development of photography in the 1800s added a new element to astronomy. The first images of the moon were captured in 1840. However, due to the very long exposure times and the need for the plate to remain wet, the process was very crude for astronomical applications. Because of this, astronomers focused on the sun for most photographic experiments. In 1871, with the advent of dry plate photography, many new images were possible. However, it was not until 1883 that a photographic image was able to show objects fainter than those visible to the human eye. The first such image was that of the Orion Nebula and was made with a 36-inch reflector and a 37-minute exposure time. Photography, like so many other technologies, underwent dramatic and rapid changes. From its initial development to the present day, the light capturing ability of photography has increased by a factor of 1 million. From 1883 to 1930, the usefulness of photography in the field of astronomy expanded rapidly and included the discovery of the nebulosity in the Pleiades, the spiral structure of certain nebulae, which we now call galaxies, the discovery of the sunspot cycle, the photographic discovery of comets and asteroids, the confirmation that solar prominences were indeed on the surface of the Sun and not the result of atmospheric disturbances on the Moon, the pioneering of the field of spectroscopy, And finally, the discovery by Edwin Hubble in 1923 that M31 existed outside our galaxy. Hubble measured the distance to this and many other galaxies and nebulae, and it is for this work that the Hubble Space Telescope bears his name. Please select another time period for further historical information.